Hello my dear student. Now I am going to discuss very important topic, defects of vision or eye defects. Defects of vision or eye defects and their correction I am going to discuss. So mainly we have corneal defect and they are of 4 types. Defects of vision are mainly of 4 types. Number 1 is myopia, number 2 is hypermetropia, number 3 is presbyopia. So among these 3, if you compare the length of the alphabets, the lowest alphabet is in myopia, and that is why it is also called as near short-sightedness or near-sightedness. ये जस्ट मैं आपको याद रखने के लिए कह रहा हूँ कि अगर स्पेलिंग छोटा है अल्फाबेट्स तो ये शॉर्ट साइटेडनेस कहलाता है. एंड द नेम गिवन टू द डिफेक्ट दैट विल बी विजिबिलिटी. दैट myopia means near sightedness or short sightedness means the person suffering from myopia can see objects situated to nearby to us. The person is not able to see distinct and clear image of the distant objects, far away objects. Similarly, in hypermetropia, it is called as far point or long sightedness. Far sightedness or long sightedness means person suffering from hypermetropia, they can clearly see the objects situated at infinity or at distant points. But nearby objects are seen blurred. You cannot say that it is not seen. The nearby objects can be seen blurred. And in the presbyopia, it is also called as old sightedness. Old sightedness, the both type of defects will be there. Neither nearby objects nor far off objects can be seen by the hypermetropic presbyopic eye. So I am going to discuss one by one. This is astigmatism or bindukta, means you will see the more than one object. Object is only one, but when you are suffering from astigmatism, so you will see 2 or more than 2 objects. That type of defect is called astigmatism. I will explain it one by one. Okay, one by one I am going to explain it. So first of all, I am going to explain myopia. Myopia, this first one. What is the cause? Why this defect is causing? First of all, nearby objects are seen clearly, but distant objects are seen blurred. Not seen, you cannot say not seen. It will be seen, but it will not be clear. It will be blurred. So if such type of happening with you, then surely you are suffering from myopia, nearsightedness or short-sightedness. In this defect, what will happen? In this defect, image of an object is formed before the retina. Before the रेटिना. रेटिना से पहले, आई बॉल में रेटिना से पहले इमेज बनता है. इट विल नॉट बी ऑन द रेटिना. सो इन दिस defect, image of an object, where is the object? Nearby objects are seen. Image of a distant object. Distant, you can see here, you can write a distant object is formed before the retina. Distant object is at infinity, whose image will be formed before the retina. If it is not forming on the retina, then how can the retina will change it into electrical signal? The function of retina is, it is changing light signal into electrical signal. So it will not change the signal and we will not be able to see the objects. So this will happen. So I am showing you in the diagram also that the object is defective. This if the eye is defected with myopia, then that eye is known as myopic eye. That will be myopic eye. What happens in this case? So we can see this is eyeball, our eyeball, lens and retina. So if the object is at infinity here, it will not be, rays are coming from the object which are infinity, that will be taken as parallel. So it will be before retina, it will meet before retina, image is formed here and retina is here, lens is here. So this is myopic eye. This is myopic eye, suffering from some disease. But this object, if this is least distance, LDDV, I have told you that it is least distance of distant vision, 25 centimeter. If the object is here, it can see. What happens if you start looking at the far distant objects? You are not able to see clearly. Take the object closer. A point, you will get a point on which, if the far object is brought to that point, you will start looking over it. That object will become clear and distinctly. That far point, this is a point. If the object is taken here, what will happen? The image will be formed on the retina. Image will be formed on the retina. So this is the far point for myopic eye. Far point for the myopic eye. What happened? क्या हुआ? The far point which was infinity for the normal eye, that reduced to some extent. ये यहाँ पे आ गया. फार पॉइंट जो इन्फिनिटी होना चाहिए वो घट करके इतना हो गया. ठीक है? So it is at distance small d, and this distance of distinct vision is denoted by capital D. So in this case, in myopia, far point of the eye reduce हो जाता है. Near point remains same. Near point remains same. It is capital D and it is small d. Now the far point is not infinity. So what is the cause? क्या कारण है? किस कारण से होते हैं ऐसे? What is the cause of myopia? Cause of myopia. Number 1. किस वजह से ऐसे बीमारी पकड़ती है? Why? It causes due to excessive of curvature of eye lens, increase in the curvature of eye lens. So due to increase in curvature, or if the curvature increases, what will happen? Power of eye lens increases, power of eye lens due to increase in curvature or power of eye lens. Number 2, due to decrease in focal length. Due to decrease in focal length, it causes, because if the focal length of this eye lens decreases, what will happen? If the light is coming from infinity, it will concentrate before the retina. If it becomes more thicker, what will happen? The power will be more, but the image will be closer. This is the reason, or you can say elongation of the eyeball. ऐसा भी कर सकते हैं कि if this eyeball is here fixed, if it is elongated, what will happen? Retina will move back. So third point you may write, due to increase in due to increase in due to increase in size of eyeball. Due to increase in size of eyeball, what will happen? The image will become formed before the retina. Retina has now elongated, it has pushed back. So due to, this is the 3 reasons due to which myopia can cause. So how can we correct it? Correction of myopia. It cannot be rectified 100%. So it is corrected by using a diverging lens, that is concave lens of suitable power or focal length. It can be corrected by using the diverging lens, or concave lens of suitable power or focal length. So let us see how it is corrected. कैसे हम लोग इसको करेक्ट करते हैं, ये देखते हैं. What is the function of the diverging lens in this case? What will be their function? What is the function? So I am making first the ray diagram, as it was not able to see the distant objects. So light ray is coming from infinity. This is from infinity. Object is at infinity and light is coming from infinity. So in the path of this light ray, if we place here a diverging lens of suitable focal length or power, what will happen? What will happen as it diverges? Here again it is diverges. Now let us explain it. The object is at infinity, which is not clearly seen by the myopic eye. So you have to correct, you have to place a diverging lens of suitable power and focal length. It is placed in front of our eyes. What will happen? The image of the object situated at infinity is made on the reduced far point of the myopic eye. Image of an object placed at infinity is formed at far point of myopic eye, from where myopic eye can itself see the object. This is the function of lens. This is the function of lens. Object is at infinity. This is myopic eye. Its near point is 25 centimeter, but far point has reduced, and the far point is this one. This is small d. Previously I have written. This is a small d, and here is the near point. It is capital D, 25 centimeter. So this position is far point of the myopic eye. Normal eye has far point infinity, but that has reduced, and this is the point, far point for the myopic eye, up to which objects can be seen. The range of myopic eye is 25 centimeter to reduced far point. If the student is sitting at the last bench and he is not able to see the blackboard, but if that student is brought nearer, he can see the object, he can see the blackboard. So this is the range, 25 centimeter and reduced far point. This is the reduced far point. What happened that this diverging lens makes the image of the object which is at infinity on this far point of the myopic eye, and from where this eye can see the object, and thus the image is formed on the retina. This is the correction of the myopia, and this is the function of this lens also. इस लेंस का ये फंक्शन भी हो गया, और दिस इज द करेक्शन. सो नाउ क्वेश्चन अराइजेस इन योर माइंड दैट what will be the focal length or power of this lens? What will be the focal length and power of this lens? Let us calculate for that. Now what is happening here? Where is object placed? So object is at infinity, and object distance is always taken as minus. Where the image is formed, the image distance from this lens is d. We are taking here d, and the object and image are in the same side, so it is taken as negative. Now using 1 by f is equal to 1 by d minus 1 by u. This is the thin lens formula, where f is the focal length. So we can write 1 by f is equal to 1 by minus d minus 1 by minus infinity. So 1 by infinity is 0, therefore 1 by f is equal to 1 by d minus d. 1 by f is also termed as, this is the f is equal to minus d. This is the focal length. Negative sign shows here that the lens is diverging lens. Power is equal to 1 by f is equal to, we can write here minus 1 by d in meter. in meter. It may be in centimeter, but it should be in meter. Then only we can write here diopter. So this is the formula for power. Power is equal to minus d. 1 by minus d. This is this diopter. Capital D is diopter. So this is how we can calculate the power or focal length of the lens required for the correction of the myopia. Okay. In next video, I will explain the hypermetropia. Thank you.